Okay, so let's do this one. Find, actually, so let me just point out, this was, look on homework 3. I did the solutions for the maximum principle on homework 3. Not going to do it all over again. Okay, find a function g of theta that satisfies Laplace's equation in polar coordinates. What is its representation in Cartesian coordinates? Where is it defined? Okay, so first, we've got that, and again, I just use this r theta notation. It's there's reasons it's not great notation, but I just use the r theta notation to say it's the polar, the Laplacian polar coordinates. Whoops, it's the double r derivative plus, and I got this backwards on the homework 3. I fixed it, but this is what it is. And then plus okay, so let's see, what does it not like? Oh, because I haven't done the gosh, okay, I need to fix this for my template so I'm not having to do this every single time. Okay, now I got to be careful here because I don't want to click on Math 412 test 1. Let's do homework 3. Okay, I think this is going to get it for me. I'm going to go back to homework 4. Oh, I need to just put the commands up here. It's so exhilarating, I'm sure, to see me doing this. Okay. So if u is a function of theta, this is, well, okay, it's going to be very good. So u of theta, this is just going to be equal to this times u double prime of theta. So if u is a function of theta, I'm going to say the Laplace equation is the following, and this is equal to 0. That is g of theta is equal to some constant times theta plus b. So let's see what we have here. Okay, so this is exactly what we get. So the constants, I don't really care about the constants, so it just says find a solution. Find a function g of theta that satisfies Laplace's equation in polar coordinates. I mean, I guess one smart aleck answer would just to be, say, b is a constant. I guess that's technically true, but a theta is kind of what I'm looking for here. So then g of theta is g of theta equals theta is a solution to Laplace's equation in polar, And notice that, like, one of the things that I'm doing here, notice if r is equal to 0, so u double prime of theta is equal to 0, that is, sorry, I should say u of theta here. Okay, so I'm looking at this equation, and I'm deducing that u double prime is equal to 0. When r is equal to 0, we have a problem here because this is not defined. So this says that, if you look in polar coordinates, when r is bigger than 0, u double prime is equal to 0, and so u of theta is a theta plus b. And so g of theta equals theta is the solution to Laplace's equation in polar coordinates. So what this means is that in polar coordinates, if you look at a point in polar coordinates, you've got an r and a theta, and I'm saying this function only depends on theta. So like if you look at kind of like spokes or rays, I guess would be the math term, going from the origin, to the boundary, or the origin to infinity, g of theta is going to be constant on that. It's going to be whatever theta is. But now look, there's a problem when r is equal to 0. Precisely where there's a problem here, there's a problem where when r is equal to 0, because the origin theta is not defined. Okay, we also have another problem with g of theta equals theta, and this is what happens if we start at theta is equal to 0 on the x-axis, and we go around like that, or from your perspective, I guess it'll look like this. But as we go counterclockwise, theta is increasing, and eventually it's going to come back to where we started, but it's 2 pi, and it's 2 pi there, but it's also 0 there. So there's this ambiguity. So somebody mentioned in the comments about doing branch cuts, and basically what we do is we just look at going around the complex plane once, and just say it's like maybe not defined on the part of the axis going from the x that it's not defined on the positive, that theta is not defined on the positive x-axis. Otherwise, we either get a discontinuity or we get a discontinuity or an ambiguity, like a double definition there. Anyways, in Cartesian, this is, I'm going to say, use the same letter again, u of xy equals arctan of y x, because remember that's what theta is. That's how theta and x and y are related. Now, okay, there's problems here. You know, when we're just kind of going back and forth in polar coordinates or something to, you know, say this polar coordinate is equal to that Cartesian coordinates, we know how to deal with this. You know, arctan gives you an angle from, you know, from minus pi over 2 to pi over 2, and that sort of thing, and then you can adjust that to the case where you have an angle in a different one of the quadrants. But as a function, this is what it is. And you can actually verify for yourself that on its domain, this is a harmonic function. In other words, take the double x derivative, take the double y derivative, add them together, and it's equal to 0. So on Cartesian coordinates, this is u of xy is equal to the arctan of y over x, and the domain is all x comma y, such that x doesn't equal to 0. Whoops. Because if x is equal to 0, we have 0 in the denominator, and it's not defined. But for all other values of x and y, we're going to get something that makes sense here. Remember, the domain of arctan goes from minus infinity to positive infinity, so we can put anything there. Now, if we wanted to, one thing that we could do is we could modify this. We could say u of xy is equal to arctan of y over x. When x doesn't equal to 0, then we could say something like it's equal to pi over 2 when x is equal to 0 and y is bigger than 0, and it's equal to minus pi over 2 when x is equal to 0 and y is less than 0, and then it just has to be not defined at 0, because then we have a true ambiguity there. That would be one way to define it. But you can also just tell, but I'm just going to leave it like this, since this is sort of the most straightforward way to leave it. Okay.